You can see it. Thank you very much. You're my guide. Somehow I move this little screen where I see our faces, and then when I do the recording, still shows, but nonetheless. So this is going to be a very brief tour of logarithmic functions. Hopefully it will be an interesting ride. It's going to be short. Hopefully it will be interesting. So I hope you come along. So let's get going. So day 21. So we have day 21, 22, and then 23, and we're done. So we're going to do today an initial tour of logarithmic functions. We're going to do a mini lesson because some of the stuff may be familiar to some of you, but not all of you, about exponential and logarithmic form. We're going to talk about what is the meaning of logarithms. And then, of course, we're going to do a little Jamboard. We're going to do a logarithmic Jamboard. It sounds like a nice piece of music. When I wrote that, I thought, that sounds like a new trend in music. Then if you want to ask Amanda some questions, we'll have you do that. And I think she will answer your questions. And then we have a Desmos investigation that is a world premiere that I finished today. So we'll see how that goes. And of course, I'll stay there for question and answer. So let's start with this. This is kind of a bit of a new-ish territory for some of you, but not for all of you. But we're going to start with this very, very basic idea, right? And we're going to look at powers one more time. But, oh, there's Kishan. We do this in math that sometimes is fascinating. We look at things sometimes from different perspectives. And by looking at things from different perspectives, we get different insights. And this is exactly, I think, the case of what we're going to talk about today. So we have something like this: 2 to the power of 3, or 2 cubed equals 8. 2 times 2 times 2 is 8. And this is what we would call a power. And then, of course, if we do a little anatomy of these, the 2 is the base, the 3 is the exponent, and the outcome is the power. So we, I think, all understand this idea. There's John. We all understand this idea of the power, right? I take a number, raise it. At least at first, we have this notion that it multiplies by itself however many times as we have here, and then the outcome is a power. Okay, so from here, all of a sudden, we look at things slightly different. So instead of looking at this in this form, we literally rewrite it in what we call exponential form. And if you look at it, this reads logarithm base 2 of 8 equals 3. And if you notice, obviously, we're kind of playing with the same numbers. We just shuffle them around. And this is how we shuffle them around. The base stays the same, right? The logarithm base. And by the way, notice that these little 2 is what we call a subscript, right? It's not a big 2. It's kind of the equivalent of the exponent, but on the bottom is a subscript. Logarithm base 2, so the base stays the same. The power now becomes this value here, logarithm base 2 of 8. Well, guess what? That's where our exponent goes. Logarithm base 2 of 8 equals 3. This we call logarithmic form. This we call exponential form, which is, I would say, kind of self-explanatory. So we're going to delve this a little bit more. In other words, the logarithm answers this question. The logarithm, if you recall from the previous page, is the exponent. So the question is this: if I take the base, what exponents do I raise the base to in order to get this power? Right? So the logarithm is the exponent. So by looking at this expression, if I didn't have the 3, I can think I need to take the number 2, raise it to a certain exponent, and the outcome is going to be 8. I hope this makes sense. I know many of you are familiar with it. If there's something that it doesn't make sense, please feel free to unmute yourselves, or please put a note in the chat so then I can see it. I can now learn how to see the chat even when I'm doing this. So please do not be shy. Okay. Good to see you, John. Don't worry, you were late. It's always good to have you. All right, so here's the idea, right? Here's the basic key idea. If we understand this, life will be simple. So we're gonna try to do a little this interactively. We're gonna try to do two activities that are gonna be a bit interactive once we have kind of understood this basic idea. So we transform the exponential form into logarithmic form, and what we're seeing is that the exponent is what answers our logarithm. The base stays the same. What exponent do I need to raise to arrive at 8? Okay, so we're going to try this. Let's see if we understood this, okay? I'm going to give you here an expression, and I don't need you to do calculators. We're not going to use calculators today. You don't need it. You're too smart for that. So here it goes. I want you to, based on what we just said, I want you to look at this and see if you can determine what exponent do I need to raise 3 to I arrive at 81. And when you have that, can you please either, you can just unmute yourself and say it out loud. And as always, I don't care if you're wrong, or you can put it on the chat. I think I heard something. Did I hear something?
That's 3.
Sorry, who was this?
Sabahat.
Sabahat. Sabahat believes it's 3. Okay. And what made you think that, Sabahat?
Because like the exponent of 3 power 3 is 81.
Okay. So if I go 3 times 3, that gives me 9. And if I go times 3 again, that gives me,
Oh, no.
you're on the right track. You're totally on the right track. That's okay. You know, it's okay. No biggie. It's okay. Good, good, good. All right. So I'm looking at the chat and I'm seeing Annie, McKenna, Inalua, all saying 4. So is Susan. Okay. And so just by sheer majority, we're going to go with 4. Okay. So 3 to the power of 4 is 81. And Sabahat, you were on the right track. You just were short 1 power, but your logic was pretty sound. Nice. Okay, congratulations. You just solved your first logarithm. Okay, here's another one. Okay, I'm here. I'm seeing the chat. Oh my, it's coming fast and furious. Cool. Nice. Okay, so what I'm seeing in the chat is everybody's writing 13. Just kidding. 2, of course, 2, right? So 5 to the power of 2 is 25. And totally people are getting the hang of this, right? Excellent. All right. One more. Okay. So logarithm, and this is how we read this, and I'm sorry if I'm being reiterative. Logarithm base 10 of 1,000 equals what? Yeah, and feel free to unmute yourself. That's okay. That's extra daring. And all right. And if you haven't taken a moment to just put something on the chat, I'm seeing a lot of answers. Some of them correct. All right. Okay. Oh, so I see 3, 3, 3, 3, 3, 3, 3, and guess what? You're right. If I take 10 to the power of 3, I arrive at 1,000. 10 times 10 times 10. Very good. Okay. This is too easy, so we can only do it for so long. And you know, I don't give you like a lot of worksheets and stuff like that. So let's try this one. Logarithm base 17 of 1. Okay, look at you. You're impossible to trick today. Okay, so, well, this kind of goes back to the connection that exists between logarithmic form and exponential form, right? When we have any number to the power of 0, we know it's 1. So the base could be anything. Logarithm 1 of anything is 0. Excellent. Okay, but you know what? Because you guys are so good at this, we're going to do 4 more, but this time we're going to do them a bit differently. Okay, we're going to go to our Jamboard, because if we don't do Jamboard, it doesn't feel like we're in class. Welcome, logarithms, and our guests. So we are going, this actually is out of order, so forgive me for that. But what I want you to do is get to the logarithmic Jamboard. And the logarithmic Jamboard looks like this. Oh, look at this. I'm not going to look at it right away. So, because people are already writing on it, but I do need you to do me a favor. I need you to kind of collaborate with your partners. And the ones we did, you don't have to do, but you can if you want. And the ones that are missing, those are the ones that I want you to work on. And I'm going to go somewhere here. So I'll let you work on the Jamboards for a bit, okay? And then we'll come and debrief it. Okay, so the first 1, 2, 3, 4 we did successfully. And now these one is kind of meanish of me to put, but since you guys were getting so good, if we don't challenge you, then what's the point? Okay, so let's think about these one for a moment. And let's go back to the key idea that we discussed, that if I have the base of 4, I need to take 4 raised to a certain exponent to arrive at -16. So group 1 believes the answer is 1/4. So if I take 4 to the power of 1/4, what would happen? I'm not sure what that might give me. I guess I could determine that. But one thing I can see that it's not really going to get me to a negative number. It's going to get a smaller, but it's not going to get me to a negative number. But this is good good logic. They're thinking 1/4. Let's see group 2. They thought similarly, 1/4. And so now I want you to keep this in mind. 4 raised to what power is going to produce a -16, which is kind of a mean question. Here, this team figure it would be -2. So let's talk about these for a moment. If I have 4 to the power of -2, we way back learned that this is 1/4 square, right? Which ends up being 1/16. It's a good approach, but this is not negative. But good. We can see why. There's our Braden. Okay, we can see why this team thought this. Team 4, yeah, they're like, not sure, and that's okay because it was a bit of a tricky question. Okay, and then group 5. Let's see, our Jamboard is getting tired. Yeah. Did I miss group 4? Or? Group 4, group 5. Same idea. The thinking is 4 to the power of -2. And we kind of already saw that kind of doesn't work. This team just put an X through it. That's team 6. I don't know if team 6, if you want to elaborate on this, Inalua and Kate, why did you just put the X? You can unmute yourselves if you want to. Or you can put a note on the chat. That would be just fine too. No? Okay. All right. If at some point you want to unmute yourselves and tell us what were you thinking here, or maybe you didn't get to it. So, okay. So this is proving to be a bit of a tricky idea. Oh, look at this. We arrive at team 7. And then team 7 is saying undefined. They're not sure about this value or not possible, right? Every now and then we arrive in math at situations like this. we talked about earlier, when we divide by 0, things become very unusual. And when we think about this, we begin to realize that there isn't a number that we know of that we could raise the number 4 to that power and arrive at negative 16.
It's 1/2.
Sabahat believes he's 1/2. Okay, just give me, let me go back for a moment, Sabahat. I think we did this a little bit. Take a look here. Oh, 1/2. Oh, excuse me. You said 1/2. So let me go to, I'm going to go to a blank page here.
Like 1/2, like, I mean, 1 to base is 4 and power.
Let me see. I'm going to write it here, Sabahat, and you correct me if I didn't interpret it correctly. 4 to the power of 1/2. Did I get that correct?
Yep.
Yes. Well, this ends up being something a bit different. Let's do a micro tour. Okay, Sabahat, let's do this, you and I and everybody else, very quickly. Let's think about this. What is 4 squared? Can you tell me that?
16.
Yes, ma'am. Beautiful. I should have done these before. 4 cubed. What would 4 cubed be? And anybody knows it, just say it out loud, please. So no problem. So 16 times 4. Oh, Suzanne just put it on the notes. Feel free to unmute. 64. Okay. Now we're gonna build a. Sorry, this is very unorganized. It's impromptu. So I'm gonna do something here. Hold on just a second. Let me move this thing out of the way. That's better. Okay. So now let's proceed here. What about these? What is 4 to the power of 1? Sabahat, can you tell me what's 4 to the power of 1? Or anybody for the matter?
4.
4, thank you. Okay. So 4. Okay, and then let's do one more. I'm gonna write this pretty. Let's do one more. See if I can write it nicely here. 4 to the power of 0. Yeah. And I believe we establish
1.
1. Thank you. Okay, so let's see this pattern if we can, Sabahat. What do you notice is happening each time? From 64 to 16, and then from 16 to 4, and then from 4 to 1. Can anybody, or Sabahat, can you give me a description of what you think is happening?
It's coming down like every time.
Yes, and how is it coming down? What is happening from 1 to the one below?
So you're taking one exponent down.
True, that's a very good observation. So I'm taking one exponent down. So then I would have here 4 to the negative 1. And what would I end up on the other side?
Negative 4?
Well, think of what you just told me. 64 to 16 to 4 to 1, and then? If anybody has an input, just please write it or tell me. Feel free.
4?
Keisha tells me 0.25. I think it's Kishan, sorry. I don't know if you have a microphone, Kishan, and if you could explain us why you think is 1.25 or a quarter. 1 divided by 4, says Suzanne. Well, let's take a look at the pattern. Sabahat is right. The exponent is going 1 down, 1 down, 1 down, 1 down, right? And what we're seeing here is the value each time the exponent goes down is smaller. How is it happening? We're dividing by 4 each time, right? Because if we go this way, we're multiplying by 4 each time. Now we're dividing by 4. So 64 divided by 4, 16 divided by 4 is 1, divided by 4 is 1/4. And then therefore, if I had 4 to the negative 2, it would be 1 over 16, and so on and so forth. But now we have this situation that we have 4 to the power of 1/2. And what happens when we multiply two numbers with the same base? What happens to the exponents? What do we do with the exponents? Would anybody like to enlighten us a little bit? So if I had something like this, 3 squared, and I was multiplying it by 3 cubed, sorry for my cube, oh dear, imagine that's a cube, I would get 3 to the power of, Karen is saying add the exponents, so I would add them, wouldn't I? Yeah? Sabahar, do you agree with that?
Yep.
Yes, good, good. I'm glad we are agreeing, because soon, hopefully, we will still agree. Okay, so now what happens when we have this? I leave the base the same, right? And what do I do with the exponents? 1/2 plus 1/2, where do I arrive?
2/2.
Yes, and 2/2 equals 1. Does that make sense? Yeah, 1/2 plus 1/2 gives me 1. But this is tricky because that means that I'm multiplying a number by itself and I get 4. Does that make sense, Sabahat?
Yep.
Okay, so let me ask you the question differently. What number times itself gives me 4? And if anybody, say it again.
2 by 2.
That's correct. 2 times 2 is 4. Okay, now let's talk about this for a moment. If 2 times 2 is 4, and we said this thing is the same as 4, okay, let me go here. 4 to the power of 1/2 multiply by 4 to the power of 1/2, and that gives me 4. Oh dear, do you see that these are actually the same number? So 4 to the exponent 1/2 is literally the same as 2. Can you see that?
Yeah.
Okay. Oh my dear. So then, to make a long story long, we just realized that 4 to the power of 1/2 is not a negative number. It's really 2, which, if we look at it differently, some of you will recall that this really is equivalent to the square root of 4. So nice idea, Sabahat, but sadly, no. So in other words, we're back here to our group 7, and group 7 is beginning to or realize that this does not exist. And to kind of summarize this idea, because we cannot find a number to which we raise the number 4 to that exponent and arrive at a negative outcome, this is not defined. In other words, there is no logarithms for negative numbers. So this is one of the kind of key ideas of logarithms. The other ones, this one, logarithm of any of any base would be 0. The logarithm of a negative number does not exist. And then this is group 7. So let's stay with group 7 for a moment. They tell me the logarithm base 2 of 1/8 is 3. So would anybody in group 7 unmute yourselves and tell us what you saw here, please? And let me see who is in group 7.
Yeah, I can explain that one.
Thank you, Suzanne.
So to get a fraction result like 1/8, when you have a base that's a whole number, you have to be looking at a negative exponent, because 2 to the power of -3 means 1 over 2 to the power of 3.
Beautiful. So let me paraphrase, not rather than paraphrasing, just repeating what Suzanne just explained so eloquently. If I were to put these in logarithmic form, exponential form, excuse me, this is equivalent to this. 2 to the power of -3, which based on our old exponent laws is 1 over 2 cubed, which happens to be 1/8. Thank you very much. Cool. So we got this one as well, and now here our group 8, which we never got to them. They had this right. Logarithm of now there's something I want to highlight here, because I think there was 1 or 2 teams that picked this up very quickly. Take a look here. Right? There's no base here. So this group did recall that when we do not specify a base, we by default believe we know it's 10. That's just a convention, right? So I think that was the only group that, yeah, here it is. I think is just 10, because when there isn't one, it's usually log 10. So you're right. Group 5, 2, good job. Base 10, so good job. So when we do not see a base specified, we immediately default to base 10. Very nice, very nice. And then the last one I didn't want you to do with a calculator. I don't think anybody did. Log base 2 of 15. I think pretty well all the groups realized that if I take 2 to the power of 3 is 8, 2 to the power of 4 is 16. Okay, so it's between 3 and 4, but because 16 is closer to 15, it's going to be closer to 4 than to 3. So that's correct. So it's about 3.9-ish, right? And I think everybody got that. So a few key ideas here. Logarithm of 1 for any base is 0. A logarithm of a negative number no existe, or it doesn't exist. And a logarithm of a fraction would end up being a negative value for the reasons Suzanne explained. When we do not have a specific or explicit base here, we know is defaulted to 10. And based on what you already understood about the meaning of a logarithm, you can estimate, you can approximate any logarithm without a calculator. So I strongly suggest you do that when you have logarithm questions before you go to the calculator, so you have an idea of what the value is, and then the calculator will verify that. Awesome, thank you. I enjoyed that. That was very, very good. And I'm gonna share just for one more moment. Excuse me. I'm gonna go here. And Steven, you said this is let's see part 2? Yeah, okay. So of course I'm recording this, but this is just the review. This does not exist, and I'm gonna put this up. This is a negative number. The base 10 is implied, and this was -2, and this one you approximated. Very nice, excellent. Okay, thank you. All right, so we're gonna pause for a moment, and I'm going to go to the next page here. Oh, am I still sharing? No, I am losing it. I share. This sharing business drives me crazy. Okay, so here it goes again. Thank you, Stephen. Okay, so this is Amanda Garcia, and this is her title at the University of Waterloo. So Amanda, maybe you want to introduce yourself, and then friends, feel free to, you can either ask questions on the chat, or you can just ask questions, period.
Sure. Hi, everybody. Thanks so much for having me in your space. So like it says on the screen, I'm what's called a lecturer. That just means that I am teaching focused rather than research focused. So I typically teach about 3 courses per year. I just started in September, so I've taught first year courses. I've taught linear algebra, first year linear algebra course, second year linear algebra course, and I will be teaching second year calculus in the fall and first year linear algebra in the fall as well. So part of my job is teaching, and then the other big chunk of my job is coming up with what's called digital assets. So we're trying to put together a robust and kind of nice suite of online courses at the University of Waterloo. So we're trying to put together, those linear algebra, calculus, all the way up to 4th year courses. So part of my job is designing those courses. So figuring out what needs to go in those courses and some interactive components that we want to put in there. Yeah, so that's a quick overview about what I do. I want to leave a lot of time for questions if you have any, so I'm happy to take your questions.
Okay, is the bomb shelter still at Waterloo?
I did not know there was a bomb shelter. Where is this bomb shelter?
Mr. Garcia, do you know what I'm referring to?
No,
No?
I don't.
Okay, it was a pub.
Oh, I see.
yeah.
I see.
I think they closed it, but I'm not 100% sure.
I thought I had heard that.
Yeah, I don't know
I-
if you're trying to revive it for like COVID times or something, like some kind of online incarnation of it, but I think it was closed down. I thought you meant like a literal bomb shelter.
I actually thought it literally as well.
But that
I
makes
thought I
sense.
might catch a few people on that one. Yeah, I went to Laurier
Okay.
Oh,
for my
neighbors.
undergrad. But we had the turret, which was better than the bomb shelter. So
Cool. So there's a few questions, Amanda. You can see them on the chat.
Oh, sorry. Yeah.
Stephen is asking why Waterloo. I believe Jane was asking what was your inspiration to become a. I'll let you read them.
Yeah, sure. Okay, so I'll try to get these in order. So why Waterloo? Well, so I did my undergrad at the University of Ottawa. And I went there because it's a bilingual university. So I did all my high school in French. So like French, not French immersion. So I wanted to make sure that I kept my French up to not, forget it or lose it. So I did my undergrad at Ottawa. And then when I realized I wanted to go to grad school for math, University of Waterloo is one of the best math programs in Canada. So I wanted to be somewhere where that would be, there's just math everywhere and you have a lot of interesting people with interesting ideas that you can exchange with. So it's a really nice environment. And then once I came to Waterloo for my graduate studies, I kind of got involved in the community. So I know a lot of people and I'm comfortable with a lot of people. So I just kind of wanted to stay where I was happy and where I think I fit in well. So what was your inspiration to become a teacher/lecturer? That's a really good question. So I actually, how far back should I go? I did not start out my career thinking that I wanted to be a teacher or lecturer. I am by nature an extremely introverted person. And if you had told me in high school that I would be teaching and standing in front of classes and talking to people, I would have not believed you. I was sort of a gradual, slow burn kind of thing. So when I got to grad school, I registered for a certificate in university teaching program. So just like going to workshops and doing a few like practice lectures. And I was like, okay, that's not bad. Like that was kind of fun. And then I actually got a few TAs. So I was actually going to classes and giving tutorials. So like solving problems for people or grading stuff. And I was like, okay, this is, kind of interesting. And then I did a little bit more professional development. And then I actually got to teach my own class. And when I taught my class, that was sort of when I realized, whoa, this is really fun. And I realized that I was starting to like plan my lectures like all the time. Like that's all I was thinking about, and I wasn't thinking about research or other stuff. So that was a pretty good clue that it's something that I wanted to spend time on and do professionally. Is RIM still associated with U of W, or does RIM still exist? So RIM is Research in Motion. So that's the company that made Blackberries at some point.
Mm-hmm.
I think they might exist, but like really small now. So they used to have offices like right next to the university campus, but the university bought all of those buildings, and there's like university stuff in there now. So I'm not sure if they still exist or if they just have like a really small leftover thing, but I think Blackberry is sort of not where it used to be.
Not even close. Okay, no, I was just kind of curious.
Yeah,
I
yeah.
seem to recall it was sort of an offshoot somehow, but I didn't know how.
Yeah, it was like they basically had offices like walking distance from campus.
Mm-hmm.
There's a lot of tech companies that are around Waterloo because they know that we have university students, and a lot of them are in the co-op program, so it's very easy for them to get like, you know, temporary employees and stuff. So yeah. Any tips for post-secondary to keep in mind? Yeah. So let me see if I can give a succinct answer to this. I guess there's sort of, I might split it into like a few different components. So like on the like academic side, you know, study. I know it sounds a little bit trivial, but you really do need to study and try to keep on top of things. One thing that's really underused, and I know this as an instructor, are office hours. So office hours is basically time that your prof will set aside, usually a couple hours a week, where they're just in their office and you can drop in and ask them questions about, you know, whatever went on in the class or in the lecture. And it's basically you get like one-on-one time with your instructor. And I find that my students don't use it very often. And, you know, I think it's a good idea to go just, you know, have a conversation with somebody. A lot of the times they'll be in large lectures. And this is a really good way for you to have like a good one-on-one relationship with your prof, to ask them your questions. It can be a little bit intimidating to go to the office hours, depending on your prof, but I do encourage that. Or if not your prof's office hours, like your TAs will probably have office hours as well. So keep that as a resource. You know, try to, if you're somebody who is good at working in groups and likes to learn in groups, try to find people to study with, to learn with. You know, you can look at your classmates. Now that things are moving online, things it might be a little bit different. So I don't know what each institution's plan is, but there probably will be some ways for you to find a community online. You just have to look or try a little bit harder than you would otherwise, because you can't just turn to somebody during the lecture and be like, hey, what's going on? So that's sort of the academic stuff. I think on the non-academic side, it's really important to sort of not get overwhelmed by the academic side. So try to set aside time for doing things that you like to do, the things that, you know, that you feel like yourself when you're doing. So if that's playing sports or if that's hanging out with friends, you know, just try to make time for those things so you're not just drowning in work all the time. Trying to think of anything else that comes to mind. So like there is a little bit of a change in pace between high school and university. So typically the lectures will be more packed. So there will be more material per lecture than a high school class. So just know that that's coming. And so you'll have to give yourself like some extra time to study and stuff for midterms. So this is a mistake that I made when I started. I did not realize that the midterms would have a lot more material than my high school midterms. And I remember studying like a few days before one of my midterms, and I realized like I'm not gonna have time to study all of this because there's a lot more material than I'm used to. So just make sure that you're sort of keeping track of things as you go along. The other thing I'll make a plug for is basically just like sitting back and reflecting on your learning as you go along. And this is like not an easy thing to do, but you could just ask yourself after every lecture, like, okay, what do I really understand well? What do I kind of understand and what am I not understanding? And if you just think about those things after each lecture, that will help you, like when you're making study plans, or if you want to ask somebody a question like your prof or TA, you'll sort of know these are the things that you want to work on, and these are the things that you're comfortable with. So just kind of keep that going.
Thank you, Amanda. I do have a small question, or if you want to comment, I think Mark has a question. So I'll let you answer
Yes.
Mark questions first.
So is the Perimeter Institute associated with U of W? And if so, do you have any favorite work of theirs? So yes, there is an association between Perimeter Institute and University of Waterloo. So Perimeter Institute is, like the full name is Perimeter Institute for Theoretical Physics. So they do mostly research stuff, but they do have some academic programs. So they have a master's program, and I think they also admit PhD students. But those students will be registered at the University of Waterloo, but they will take their courses at the Perimeter Institute. So there's that kind of relationship, and a lot of faculty members at Waterloo are also faculty members at Perimeter Institute and vice versa. I am not super familiar with the work that Perimeter Institute does. I'm not in that area, but my partner is actually working there right now. So he is teaching some of the master's courses, and he does mathematical physics. So I will just say mathematical physics as my my favorite work just by default.
I just wanted you to comment, because you and I talked about this, and I know that's one area that everybody in our environment is concerned about, and I know this class has my deepest admiration, because think of the whole scenario that we have, and we have all these students that are coming here when the weather is beautiful on a course that hopefully will improve them a little bit, and they're so dedicated, and I don't know how many times they are telling me, I'm sorry, I'm going to be late, I'm going to miss this, or the assignment is going to be late, etc. So I know they are very, it matters to them a lot to do well, to go to university. So I need you to tell them a little bit what the university is planning, because the university is realizing that this is a different year, right? This situation is never been seen before.
Yeah, that's a really good question. So I can only really answer this for Waterloo. I don't know what other institutions are doing. So I know that we are planning to offer, I don't have the details of that either, but I know we're planning on it, some kind of bridge course for students who are like finishing grade 12 in these interesting times. So like having a bridge course that would help you like review some of the grade 12 stuff if you're sort of feeling like you didn't have enough time to go through the material, or like whatever, you lost 2 weeks or a couple weeks of material. So it's like, and I think the way we're doing it at Waterloo, I think it might be optional. So if you feel comfortable that you did all your grade 12 and you're like, this is good, I can go straight into calculus, you can do that. If you're like, I want to review some of the basics, I'm not sure about certain things, I think that course will exist to sort of make sure that people have the background that they need in order to succeed in the calculus courses. So that's what we are planning to do at Waterloo. I don't know what other institutions are doing, but I would imagine something along the same lines. As for like the actual delivery method of courses in the fall, we actually, at Waterloo, we don't know. So we're sort of getting very vague messaging right now. It seems like June 1st is some kind of magical date where we're supposed to get like the final word. All we know so far is any large class will be held online, but they have not defined what large means. So we don't know if that's 50, 100, 150, 20. So we're still waiting on the final word on that.
All right. Well, thank you, Amanda. Thanks for coming. I mean, you can hang out, of course. And thank you, friends. And again, if at some point, I mean, we're going to see each other 2 more times, but if you do have a question for Amanda, just because she's in that environment, you can ask me, and then I'll pass it along, and hopefully I'll get some answers for you. So good. All right. So I gonna go back here now to our D2L. Actually, I'm not gonna share the screen. If you go to our D2L in the first announcement for today, you will see a Desmos exploration. This is, some of this content might be new to some of you. We're going from exponential, I don't want to give it away because it's a bit of an investigation, but we're going from one type of function to another type of function. They are connected. So I want you to take your time. It's right now 8:05. As usual, I'll be here till about 8:35 or 40, and I will not. I will be looking at the Desmos, and as usual, if you have questions, please ask me either here on the chat, unmute yourself, or put it on the chat, and I will be looking at the Desmos, and I'll be giving you feedback right there. Okay, so I want you to take a look at what happened, say, on the first screen. Everything is connected. There's a little bit of a pattern here. You have an x value and an f of x value. So it's almost like, remember when we used to play the functions game, right? What is the connection that you can establish? And of course, you can change these values, by the way, if you want to go in order. This person went 0, 1, 4, 8, and then there's a connection here. But before the first thing that I want you to look at is take a look at the graph. And some of you may recognize what this looks like, what type of function this represents. And so take a look at, can you establish a connection? And maybe some of you may want to do something like this. So you can kind of maybe see if there's a connection that you can establish that may allow you to then come on screen 2 and make a prediction. And I know I wrote here, if you don't match, try a few times, no big deal if you're not sure. I understand that, but I'm not sure people are necessarily trying. So give it a try. It's okay if you don't get it right, but I would love to see something here because you're going to get feedback right away. For example, if I think this is a quadratic and I do one of these, oh, I realize that like this looks like is rising faster than a quadratic, for example, right? So yeah, please don't go as far as speed. Yeah, I'm beginning to see better stuff. Okay, good. So I was apprehensive about that. Give it a look, and then do take your time. Okay, I know a lot of you are very efficient, but I want you to be a bit. I want you to be thorough. Take your time on each screen. And again, if you have questions, that's it. I was just apprehensive about that, but I can see that very quickly that got addressed. Thank you. Okay, so unpause.